Sounds like a plan. All right. Good morning, everyone. Welcome to today's guest speaker series hosted by the Tennessee Tech chapter, the SME Tennessee Tech chapter here. My name is Emmanuel Gumbin, and I will be your moderator for today. And we're very excited to have our guest speaker be Mr. Nicholas Russell. He's going to be talking today about a variety of topics. But before we get started, I just want to give you a quick rundown of how today's session will go. First, Michelle will be giving a brief bio of Nick's works and what he's currently doing. Then Nick has a PowerPoint that he'll be presenting, which will be about 30 minutes about today's topic. And then after that, we'll give the opportunity for participants to ask any questions they would like to Nick. And regarding the questions, how we will be moderating those questions are, if you have a question, we'll be utilizing the chat. Just say, I have a question, and I'll call on an individual in the order of how I received that notice that you want to ask a question, and we'll moderate it from there. But with that being said, let's go ahead and get started. And Michelle, I'll send it over to you.
Thank you. I'm Michelle Davis. I'm the coordinator for the Center for Manufacturing Research at Tennessee Tech University, and it's my pleasure to introduce Nick Russell. Nick is a project engineer at Dynetics working on the NASA Human Landing System Crew Module and Lunar Dust Mitigation teams. Nick has previous work experience in the energy, financial, and manufacturing sectors, working in such roles such as quality engineer, design engineer, and engineering consultant. Nick has a bachelor's degree in mechanical engineering from Tennessee Tech and a master's in engineering and technology management from Stanford University. Now I turn it over to Nick.
All right, great. So let me go ahead and share my screen. Can I get confirmation that you all can hear me all right?
Yes, I can hear you.
Okay.
I can hear you.
And can you see my slides now?
Yes.
Great. So hi everybody. My name is Nick Russell. I'm a tech alumni, love Tennessee Tech. I'm really happy to get to talk to you today. And so, my initial kind of title for this was how to maximize early career success, because it's something I think about all the time as I'm trying to kind of shape and develop my career. But I kind of subtitles early career conversation because, one, I think it's a bit presumptive for me to think I know about success yet, right? We'll see that in 10 years. I'm just kind of getting started. But also I do want to have a conversation with you. And I hope to kind of be able to tell a lot of stories and give examples as we talk. And if in the course of that, if you have any questions, just feel free to jump in the chat or interrupt me and let me know, because I'd rather have a conversation than just show slides. But I do have quite a lot of slides and it'll go fast, but it's a lot of pictures, so don't worry. So the agenda for my talk is tell you a bit about my past so far, with an emphasis on kind of stories of what the work at each job looked like. Because that was always something that I was really curious about, even when I was, a senior mechanical engineer at Tennessee Tech. Is what do engineers in the real world in their roles really do? So I'll spend a lot of time kind of focusing on what that work has looked like in the different roles I've been in. And I've got some kind of advice while you're at tech, advice for doing the job search. So that's really, junior, senior year. Some early career advice, and then just a couple closing thoughts, and we'll get into the conversation. And so when Dr. Fadon, asked me to talk, I spent some time thinking about, well, what value can I really add? And what I finally came up with is, if you think about a career arc, is kind of following that blue line. You guys are just at the very beginning, and most of the speakers that Tech has are people who are 20, 30, 40 years into their career. They're really developed, established, successful. And so they're sort of so far away from where you guys are that they can't really relate, maybe what you're going through, with the uncertainties that you have, with the questions that you have. And they've sort of lost maybe touch with what it feels like to be an undergrad engineer. And I just graduated in 2017. So I feel like I'm, just kind of slightly ahead of you guys. And that's where the value that I can add is to be more relatable, more directly kind of answer the questions that you have as a engineering student in 2021. So now I'm going to read my resume to you. No, just kidding. So I'm kind of going to do the picture book version of my resume and talk about some of these different jobs I've had. So my very first one was after my freshman year at Tennessee Tech. I went to FlowServe and did a year-long project engineering co-op. So FlowServe's in Cookeville. It makes kind of flow control devices. So on the right, you would see what a very prototypical FlowServe product looks like, where it's a valve, some kind of flow meter, and an actuator on top. And that might go from $2,000 to $10,000, just depending on what the exact application is. And the company was launching a new product called Compact Electric Actuator that you see there on the left. And so I was brought in to kind of just help stand that product up. So the very first kind of major role I had there was dealing with a lot of sub-assemblies. So the compact electric actuator had around 200 parts, and the design engineers who were in North Carolina and India had done a great job of designing the 3D model and how the actuator would work, but we were going to produce it in Cookeville. And so we actually needed different sets of models and sub-assemblies that were just specific to the assembly process. And so I spent a whole lot of time digitally assembling the actuator inside of SolidWorks with these exploded views. So doing things like the order of operations, how are we going to divide the sub-assemblies in the plant? So we're going to have a mechanical sub-assembly, electrical sub-assembly, a main housing sub-assembly, final assembly where we're kind of putting on the caps. And so broke it out by the functional area of how we would manage the plant. Then also tested, inside of this digital model, is there enough room for an assembler to get, a gloved hand in to tighten a screw, things like that. So thinking about ergonomics. And so spent a lot of time doing complex assemblies, and then also exploded animations and kind of exploded assembly drawings, so that we had, video tools and paper tools to give the assemblers, they would understand how to put it together. Another thing I spent a whole lot of time doing, I don't know if any of you have seen this, but it's called a product lifecycle management software. So this particular one was called PTC Windchill. But whenever you're dealing with a complex product in an organization that's spread across multiple facilities, you're usually going to use a tool like this, and it sits on top of a SolidWorks or an Inventor, and it controls who can access, change, modify, request a change to a part, to a drawing, to an assembly. And this was really the first exposure I'd had to this. I don't think you get a lot of exposure to product lifecycle management in most undergrad kind of educations. But so I spent a lot of time in here. So whenever I would release anything or change anything, or for instance, if I found, hey, a part inside the assembly, it's impossible to assemble, so I needed to make a change request to say, please redesign this part for manufacturability, then I would put that request through the system and it would go to that product owner. The next kind of thing that I did in my day-to-day task was we had pin layout, and this was the kind of input, output, data connection to the actuator. This isn't an exact, the image on the left, it's not an exact replica, but very, very similar. And we needed to do some testing to make sure that whatever voltages went into this terminal and went through the hardware and software layers of the product, that we would get a predictable signal from the output. And so this was an incredibly sort of rote and mundane task where I would have basically, voltage source that would vary voltage signal, and I would apply like a voltage to the first pin and see what voltages came out of all the other pins, make sure that it was what we expected, and then apply voltage to the second pin, then the third, and then apply a voltage signal to the first and second, first and third, etc. And so just doing combinations, making sure that the hardware, the sort of as-built hardware, sorry about that, that we had in the plant actually performed to sort of what was expected. And the final task was I got to help write the user manual. And so I don't know if you've ever read a user manual, for your lawnmower or leaf blower, but they're these sort of industrial user manuals. They're really boring and they have a whole lot of legal text. And that was basically what I was doing. So I went through a multi-day training class on how to use the actuator. I'd worked on assembling it. I had worked on this kind of understanding the different input and output voltages. And they didn't want to devote, full-time engineers making big money to writing this manual. And so they basically had me sit down, and from the corporate, kind of legal team, I got an outline of, hey, this is everything that has to be included to cover our, hind end, whether it's electrical safety, fire safety, et cetera. And then I filled in, a lot of the sort of little details about the specific product in sort of a user guide template that they had. So that was really what the day-to-day work of that first job looked like. And, some of these tasks are not things that you'd think that you would be doing in an engineering job that you get a lot of exposure to in undergrad. That's why I wanted to share just what the day-to-day life kind of behind the scenes looks like there. And so the lesson from that first internship is that, your first of anything won't be your best, but learn through failure. And the reason I say that is this was right after my freshman year. I truly knew nothing about engineering. I didn't have a lot of SolidWorks background. I really didn't know how to use Outlook. I knew how to do very, very little going in. And so, just ignorance going into a job, you're going to make lots of mistakes, but that's great, and learn through failure. And something that I wanted to mention to students is that, every internship and at the beginning of every job that I've had, I feel really nervous. I don't know what I'm doing. Maybe I'm being judged, but everyone that you work with, especially if it's your first internship, your second internship, you're still in college, they, your bosses know that you're new, and they know that you're going to make mistakes. And so don't be afraid to do that, because people have they're a lot more forgiving than probably you realized and than I realized. So my next internship the next summer was at a Whirlpool in Cleveland, Tennessee. And this is kind of more of a high volume production. It's a larger plant. The Flowserve plant is more of a medium volume to job shop type of production. And I absolutely loved the Whirlpool plant. They have a great culture there. And so this, they have a microwave line, stovetop line. This is an oven cavity line. But I was working on a line that was very low volume, but very high margin for the company. And so it's commercial cooktops. And so on the left, you get examples. This might be something that you find in a restaurant or very high-end family kitchen. It could go from $10,000 to $20,000. But like I said, it's low volume. And so all of the finishing work is done by hand. And so it's grinding, sanding, like you see in these pictures. And so Whirlpool had recently relocated to a new plant. And so that had changed both the flow through the stainless steel finishing area, and with new equipment, it changed the amount of time that it took to do each of the finishing operations. And so multiple people, both the kind of personnel management as well as planning and finance, said that they really need somebody to do a process study to understand how much time it took to finish each part. And so I spent, at least a month, 8 hours, 40 hours a week, basically doing process study, where I would be down on the line, watching the employees finish a part over and over and over, and, timing each part from the time they, first reached for that unfinished good to the time they could put the finished good into a work in process bin, and how long it took, what are all the steps that it took them to finish that part, and about how long did it take. And so I did 20 or 30 timings of each operator to get kind of a good average. And then I also had to watch operators that were expert in finishing a part, kind of average in finishing the part, or brand new to finishing the part. That all went into kind of a table like this, where for every part number and name, and for every operation that happens to that part, we would get this time. And so this time goes both to finance, because as different steps are done to a part inside of a manufacturing plant, and it goes into work in process or work in progress. So as work's imparted to it, there's additional kind of money and value. Let's see. I'll try to I'll answer this question because, like I said, I want to jump into questions. So, what roles will additive manufacturing play in the projects carried out in Flowserve and other industries that you intern? So, I actually did a study at Flowserve where they asked, "Hey, we're interested in maybe getting a metal 3D printer," because they had a plastic 3D printers there for prototyping, and they were sort of sparingly used, used a few times a year. but management got really interested in metal 3D printing. And so I went out to several vendors and I called and got quotes, kind of realistic quotes, for how expensive it was. And at that point in time, a metal 3D printer required that you have a separate slab that's isolated from the rest of the machinery inside the plant. It required that you have a separate air handling system because it's handling air powder. The 3D printer, the powder handling system. So altogether, and this is for like a laser sintering kind of metal 3D print application. It was like $2 million, and that was just way above the. Plus, you needed a lot of specialized training, plus a lot of continual maintenance. So $2 million upfront cost, and then you could assume 300,000 or 400,000 a year in operational costs to keep the thing running. So I decided to not go forward with the metal 3D printer. But pretty much every company that I've been at to this point has plastic 3D printers for prototyping, and they all say they're interested in 3D printing. And I did a lot of 3D printing work with Dr. Kadan, which I'll talk about later, and I have that on my resume. And every company is interested in having people with 3D printing knowledge because they want to learn more. And a lot of people who are in industry, who have been in industry for more than 5 or 10 years, don't have a lot of exposure to 3D printing. And so it's something that all industry wants to engage in, but they're not quite there. So I'll answer these questions, and just because like I do want to have this dialogue, I think it's more valuable than me going through the slides. So have you met someone in your internships that has SolidWorks certification and got benefit with that? SolidWorks certification helps. So I actually have a slide later on certifications that will hit directly this, and we'll talk about it. But yes, I'm a huge fan of getting these certifications because they don't take a lot of time, but they add value. They set you apart. They show that you're proactive. They show that you're investing in your career. And I particularly like certifications that allow you to teach other people within your company, because then that makes you more valuable. But we'll talk about that a little later. What companies want from an internship is a learning platform or an execution platform. So we'll talk about that more. I have a section on looking for jobs. But I think early career, 4 years into your career, you really need to be focused on learning, and you need to take big challenges. So if you're focused on learning, you're going to try things that are audacious. If you're focused on execution, you might try something too small. And so even if you execute it well, it may not have an impact, it may not be impressive. But if you're really focused on learning, I think you have like more upside in the projects you do. And so for the first 4 years, I think learning is really important. I actually feel like I'm now transitioning in my career to a place where execution is becoming more important, because I'm starting to manage budgets and I'm starting to manage like other people and resources for the company. And at that point, execution becomes a lot more important. But implicit in the question, I think you're almost making a dichotomy, like it's either a learning platform or it's an execution platform. But I think it can be both, actually. And so I would lean towards learning, but you still want to become someone that can be trusted to execute. So we talked about this. This is like time study. It's very traditional sort of industrial engineering stuff. Don't be surprised if you're asked to do it. And I'm gonna have to speed up. But I was gonna say, this was another kind of a big task that I did. So it's just a visual picture of, I essentially had to convert a old Lotus Notes database into an Excel database. I won't go into the details for time. I had to create sort of a user GUI platform where it's called the part material usage sheets. And for any given part, it said, what materials do you need to produce the part? What equipment do you need to run it on? How long will it take? And the company wanted to essentially upgrade the platform it was hosted on. And the key point kind of that is that learning Excel, but like functions, pivot tables, VBA is a huge unlock. So just like we talked about, maybe a SolidWorks certification, I think spending a lot of time to get certified and get skills in Excel will be a big accelerant. And so the two things I learned about from Whirlpool. So the second thing that there is add value with Excel we talked about, but the first is also be willing to work shutdowns. So I worked a 1-week shutdown while I was at Whirlpool. So one huge benefit of it is I did 6 12s, so 72 hours, got that week, got a ton of overtime. But the other thing is this picture of a turret punch press, and I actually got to, on the left, you see that punch press looks like it's for working with sheet metal. On the right, you see what the dies look like. And so we took all the dies out of a punch press. We basically like refined the cutting edges, reassembled it. It's something that I would have never learned how to, to manually deal with a punch press. And it's just a cool thing. And because I was like young and skinnier than a lot of the guys, actually, if you can see the platform where the sheet metal, I actually climbed up under there to clean it out. And it was kind of fun, to be honest with you. So be willing to do jobs like that. So the next job that I had, it's iLight Technologies in Cookeville. So you can see from these beautiful images, they make this custom LED lighting, and they've done some really cool big projects all over the world. And so I was a quality engineering intern. So what you see here are pieces of our product that failed. So I was involved in the, it's called HALT, highly accelerated life testing. So you take these pieces, we put them in a cold chamber, a heat chamber, a water chamber, and just expose them to a lot of sort of nasty environment. Then we took that and we would create a table like this. I didn't have the exact table, but it shows the degradation of the product over time. And so you use that, you keep that data over time to learn as your manufacturing process getting better. So you're having higher quality product or lower quality product over time. Is that quality changing? Then also, whenever you're doing things like making warranties to customers, when you're doing a bid on a big project, a customer might want some kind of a custom warranty. So you can only give them that if you have data on how you're performing. Another task I did there, when we would get new product in for our suppliers, we would do some testing. So on my left, that's like a classic sort of impact test to see is the product as strong as we think it is, like the plastic housing, can it withstand hail, for instance. And on the right, since it's a visual product, we would do kind of spectrum testing, light quality testing. And so I would get the new product in, get a certain 10% of it, I would test it, record those values, and that's how we signed off that the supplier was giving us good quality products. And finally, some other tasks I did there is because it's a small company, I jumped in on production. So picture soldering, I really hadn't worked with electronics before this internship, but they had a big order. They taught me how to solder. They said, will you help us solder these LEDs and these computer boards? Because they made their custom electronics, custom controllers for the lights. So I did that. And so kind of the lesson there is, as an engineer, especially as an intern, don't be prideful and be willing to jump in on production or cleaning or whatever they need from you, because that'll set you apart, and that'll help you become trusted by your managers, that they know that you're willing to help. So the next, I did a RAU intern research experience for undergrads through NSF at Tennessee Tech. So you see me and Dr. Fidon there together. And we actually 3D printed this dinosaur, believe it or not. I hope it's still in the library. I'm not sure if it is, but I hope it is. But let's see. We got Jacob Roberts. I'll answer your question after I get through this one. And so some of the activities that we did, so we used a handheld 3D scanner to scan the bones like a real dinosaur that a paleontologist had brought in. And then we used software to repair the meshes. And so you have two kinds of 3D models, really. You have like a parametric model that you create in SolidWorks, and it's got defined edges. Or a scanner produces a point cloud, and then you connect those points and you get a mesh, but they often have to be repaired. So learned how to do that, which was great. And then we kind of 3D printed a lot of ball and socket type things to try to replicate joints. And the learning from that NSF internships really like learn the new technology. So 3D printing, like I talked about, we talked about that earlier. This was really my first exposure to it. While I was in this internship, we went to the national labs, got more exposure to 3D printer. I've actually bought a 3D printer. It's something that I still engage with. Like I was printing something just this weekend. And so learn this, and also 3D scanning is becoming increasingly important in industry. Multiple companies have had 3D scanners. They don't have a lot of people who know how to use those. I think Tennessee Tech has one that used to at least be available in the library makerspace. So if you can learn how to use that, that's a great skill. And then secondly, and Dr. John I think is really good at this, but do some things that can get people's attention and put them on your resume. So if you have on your resume that you 3D printed a dinosaur, and that Struthiomimus that we printed would normally cost like $50,000, and we did it with $400 in material costs. People are just sort of curious about that, and they want to ask you. And so having a few things on your resume that can be a little quirky, especially in internships, I think can help you start a conversation in interviews. So I do recommend that. So I'm going to answer this question from Jeremy. It's as a junior who hasn't tried to get an internship before this year, what would you recommend doing to stick out, have a better chance to get chosen for an internship? So I'm going to speed through these jobs because I do have a section on kind of what you can do to set yourself apart. And if I don't answer your question well enough then yeah, ping me again and we can even talk through it. Maybe you can jump on and we can discuss because I think it's really, really important that you do get an internship. I think it at least doubles your chances of getting a good first job at a minimum. So let's talk about that. So I won't spend much time here at all, but the next internship that I did was actually at UBS Financial Services, which is a giant wealth management company. And it's because I'd gotten into options trading. I loved finance, and I had those Excel skills like I told you about. And so just through church, actually, I met the guy who was managing about $250 million. And I told him about some of the stuff I did. And he said, hey, why don't you come work for me? I have some models I want you to work on that I can't get other resources to do. And also I'd like for us to kind of trade options and bounce ideas off of each other. So this is just some of the Excel work I did. It's not worth talking about, but the lessons here are take a chance and try something that you can only do in college. So you have so much freedom in college, guys. There's kind of you can call somebody up and say, hey, I'm a college student. I want to pick your brain. They'll probably talk to you. It's harder to do that when you're a professional. But yeah, take risks, do an internship that maybe doesn't directly relate to your professional role if it's something that you want to try, because it'll be harder to explain why you did it once you're a full working professional. And then the second thing is engineers have very valuable skills that can be used in finance and a variety of other industries. And so even if you don't love your first couple engineering jobs, keep building those skills. You have the problem solving skills. You're smart. You're a hard worker to graduate from Tennessee Tech. And so that stuff is really valuable. So finally, I graduated in December 2017. And so here's something I hadn't talked about, but actually got married, had kids at 18, which is something that is going to make college a lot harder if you decide to go that route. But I think it's what kind of pushed me and propelled me to take on all these jobs. And I worked the entire time I was an undergrad, other jobs like that I didn't speak about here, whether it's tutoring, working for athletics as an athletic tutor, worked for Dr. Fadon for like 2 years, worked at grocery stores and mowing lawns and all kinds of stuff to put myself through college. But the lesson that I got from graduating was be ready and expect unexpected challenges to pop up sort of at the end of completing anything. And so, my car broke down and I had to borrow a car from somebody to get to class to finish my last semester. Had to, basically take a loan from my mom to finish, had to take student loans to finish, had to, my senior design project, when we went to do our big presentation at the end of the year, the projector completely quit working and the teacher said, hey, this is our only chance to do this presentation, you got to do it anyways. And so things pop up, and at the end of every project, unexpected things pop up. And so I would usually give yourself on a project 10 or 20% extra time to deal with these things that are going to happen at the end. And just, yeah, it's almost like fate wants to make sure you really want something. So be ready to push through the challenges. So my first job out of college was as a design engineer at Mesa Associates. And when I interviewed and accepted the job, it was going to be doing professional services, consulting, working on HVAC mechanical systems like what you see here, which is a really good job for mechanical engineers. But when I show up the first day, they say, actually that business unit isn't that busy, but our transmission line design unit is extremely busy. Would you be willing to do this? And I said, sure. So I learned about all of the different types of engineered structures that go into transmission lines, and a lot of kind of civil statics type stuff. And then also this industry I did not know, but has a very specialized CAD program called PLS CAD that you use to design these structures and these lines. And the image on the right there actually shows that utility companies will fly the line with a helicopter. They'll get a point cloud of all the kind of shrubs, the ground, everything that exists there. And then you use that data to design the utility lines. So neat job. I was there for about a year. I really, really enjoyed it. And the lesson I learned there is kind of manuals are your best friend. So here's the NESC manuals. This tells you everything that you need to know to design a utility line and get it permitted in the United States is in this manual. And another one was PLS CAD, also has a big manual. So I printed both of those off, put them in 3-ring binders, took them with me at home, and tried to read for about an hour a night because when I started the job, I knew nothing about transmission line design. They don't teach it in school, but you can learn it. And I've actually found it's almost how every industry is that I've worked in is the specifics how to operate in that industry. You really can't learn in school. You can only learn from a job. But people have written down, and there's presentations at your companies, there's resources at your companies to learn how to operate in that industry. So you can do that. It's kind of a surprise came up when I was working there, and that was that I got accepted into a PhD program at Stanford, which was completely unexpected for me because less than about 1% of people who apply get accepted. And I really, this was the only graduate program I applied to, and it was just to get practice applying to graduate programs. My job was actually to work for 4 or 5 years, save money, and then get an MBA. This just kind of happened to hit. So the first year there, 2 things that really shocked me. One, so this whole ivory tower concept of academics in a vacuum was completely true because management science is more of a social science as opposed to engineering. And second thing, it was absolutely like drinking out of a fire hose. So that summer, I did summer research / sort of an internship with a company called Local Motors. So they 3D print an autonomous shuttle. So on the left, you see their big vehicle scale kind of 3D printer. And so the 2 questions that I was researching there was, what is the impact of like production scale 3D printing? How does that change the relationship between design and production engineers? So in the traditional automotive industry, there's a set way that these different engineering groups in the company operate. And in this company, Local Motors, was completely different. So that was really the main thrust of what I was there to study. And so what I learned is, as an engineer, you've got to gain trust of people and be wanted in the room. And so at this Local Motors internship, I needed to be in a lot of high-level discussions with the engineering managers who were structuring their teams. And I didn't necessarily have a reason to be there. But I had to ask to be brought into these meetings, and then I had to like provide value to them while I was there to keep getting invited to these management level meetings so I could understand like how they're trying to structure the company and why. And I think if you want to get ahead as an engineer, you need to learn how to get into the right rooms. And so you have to learn how to provide value even when you're like not necessarily needed. So Stanford year 2, coronavirus hit. I kind of came to a dead end in my research. I felt like I was pushing a stone up a hill, so to speak. It's probably the toughest year of my life in terms of just the workload and everything that was going on. And so the lesson there was kind of just take the next step when things seem really hard. And, again, my senior year was another one of those, because at the beginning of my senior year, I took an exhale. I was like, I'm here, I'm going to graduate. But the classes were tough. Our senior design project was really tough. And so when you feel like that, just think about how you can take that next step. So I decided at the end of the second year to sort of leave with the master's degree, and actually took it's called a leave of absence. So I was qualified as a PhD candidate. So I'm still technically a PhD candidate at Stanford, but you can leave and have up to 2 years to do whatever you want. So I said like, hey, this is really tough. I want to rebuild my life a little bit. So I'm going to take 2 years off, but I went ahead and graduated with my master's, except that, COVID happened. So graduation looked a little bit more like this, just with family. It was still sweet, right? And so, everybody that missed out on graduation or however your year is impacted with COVID, I hope that you can still find like sweet moments with the people that you care about to, celebrate all of your wins. That's important. Being an engineer is hard, so you got to celebrate the wins. And so what I learned there, so savor every moment, take nothing for granted. And, every kind of internship I'd done before this, they were kind of in Tennessee for the most part, or every experience was in Tennessee. I knew I could visit those people, stayed friends with those people. It's like when I left something, it never felt like the door closed. But like when Stanford, when you're flying away from California, and, you may not go back, that really hit me like, wow, I should have been way more engaged moment by moment. And the other thing is to have an exit plan / exit criteria. And so on the exit plan piece, when you're doing a PhD, you're not actually doing the same requirements you need to get a master's degree. And only about 50% of people who start PhDs finish. And at the end of my first year, beginning of second year, I said, I want to make sure that I at least get a master's degree no matter what. And so I created, actually like a separate plan to make sure I got my master's degree in time. And I had another friend in my year, PhD, who also took the leave of absence, but he did not, do those things to make sure that he would still get the master's degree, which required me taking about 5 extra classes while I was there. And so make sure that you've got a plan that no matter what situation you're in, you're going to get some value out of it. The second thing is those exit criteria. And so part of the reason, I decided to actually take a step back from Stanford is when I was an undergrad, I had this family, I had 2 kids, I was working so much that I really only saw my family about 1 hour a day on average. And to me, that wasn't enough. And so when I started Stanford, I said, if I'm not able to spend, at least 2 or 3 hours with my family and feel like I'm engaged with them, then I'm going to have to reevaluate. So I already had that criteria in my mind. And I wasn't being able to do that. And so when that kind of triggered that, hey, I'm not fulfilling my goal of being good to my family, then that's what kind of made me take a step back. And, if you're in a job, have those things that, if your job asks you to do something unethical, or if you have a manager that is, berating you, or, whatever these things are, have certain criteria that you're going to do what's right for yourself, and plan that ahead of time, because it's hard in the moment to make those decisions. We'll skip this. It's just saying, Stanford taught me to get out of my comfort zone, and mostly we're kind of making a lot of international friends, learning about the rest of the world. Because I had, growing up, never been out of Tennessee. And so to go into such an international school and learning about other people, I found, really fulfilling experience. So now I'm a project engineer at Dynetics, and I'm working on the product that you see there. So it's called the Human Landing System. It's being developed for NASA. It's our program this year is about a $240 million program. The program's lifetime values is about $7 billion or so, and it's literally supposed to land astronauts. So one thing that's weird about it, sorry this picture got distorted, but we're actually in a competition. So on the left, you see the lunar landing module from Blue Origin. In the center is the SpaceX Starship. On the right is the Dynetics Alpaca. And so we are literally competing against these companies continually to get more funding from NASA, which kind of makes it an interesting dynamic. So this is the crew module. On the left is a mock-up. So the crew module is essentially a pressure vessel that supports all the life support equipment that astronauts need. So, you need oxygen and nitrogen to create your environment. You need to be able to clean that air. You need to manage astronauts' waste, to feed the astronauts, to keep the amount of oxygen in the air comparable. And I could not share kind of any of the interior pictures because they're proprietary, considering that we are in this competition. But on the right, you see the interior of the space shuttle, which very much looks like the interior of our module, because we actually have all the engineers who worked on space shuttle working on our module, because it's the exact same life support systems. The other project that I'm working on is the lunar dust. And so on the right, you see what the Apollo astronauts look like when they came in from an EVA. They're extremely dusty. And the dust that's on the moon is actually much worse than the dust that's on Earth, because the dust that's on Earth gets weathered. The dust that's on the moon is essentially glass shards. So it's damaging to the eyes and the lungs, as well as to mechanisms. It's very sticky. It's electrostatically charged. And so it's really nasty stuff, and we have to kind of deal with it. So the very first project that I worked on there was essentially procuring and building a giant safety platform that is movable. So again, it's not super glamorous or super technical engineering project, but this is something that I had to get done. So this was basically my first month at the company, and I've only been there about 6 months. Next piece, so this is a work breakdown structure and a integrated master schedule. And so this would be like something that you could generate inside a Microsoft project. And so I worked on generating this for the crew module for our proposals. So I did it for the next 4 years. So all of the planning of the next 4 years of what we're going to have to build. So you start with trying to lay out every single task, and there's thousands of them, and they're hard to predict. But you ask all of your engineering managers and engineers, what is it going to take for you to accomplish this? They give you lists of tasks. You then lay them out in terms of priority, what has to get done in front of the other. And sorry, I couldn't share a lot of pictures and stuff I do at Dynetics. Because a lot of it's proprietary. But so some of the other tasks I've worked on is the crew module proposal that we gave to NASA for our cost. So that includes, integrating the labor, travel, bill of material costs. So the labor is directly tied to that project schedule, like I showed you. So you have to allocate people to all of those tasks, how much those people cost, how long it's going to take them. The bill of materials generated for what all do we need to build all of our prototypes, all of our test units, and the final crew module. And the basis of estimate is something that you have to do. It's a document that justifies your estimate. And if you're working on a government program, like anywhere in the defense industry, you have to do these. And it's like documentation that supports your cost. Supplier cost analysis. So that's like some of our suppliers would get. So I did Oceaneering, which is a supplier of like soft goods, gave us a $4 million proposal, and I had to go, or build their bill of materials, and I had to go line through line, call their suppliers, verify that is the actual cost, and challenge them. And we actually cut out about $400,000 of cost because of some sort of small errors Oceaneering made. So dust mitigation test planning. So aerospace projects have a lot of risk. The way that you reduce that risk is through test campaigns. And so I've been involved in writing the test plans for 4 test campaigns that we're executing at like NASA's facilities. So have very specialized facilities that you can do low gravity, low oxygen environments. They actually have the lunar dust simulants. So we're testing a lot of our hardware in NASA facilities. And then we have a dust control plan, which is about a 150-page document that spells out what all the risks are to all of our different systems, how we're burning down those risks through the test campaigns, and then like what we think our final risk would be. So the final lander will still have risk, and we have to feel comfortable about it. And so all that is inside the control plan. And so I'm coordinating. There's about 60 or 70 people total involved in dust mitigation activities across the program. And so I'm making sure that all of them can give inputs that can be integrated into a final good product. So I think that's the last about me. And now we're going to transition to specific advice. So first of all, while you're at Tech, I highly, highly, highly encourage you to get involved. And these are just a bunch of different ways you can do it. So, join a club, a leadership position in club, build something like your senior design project, go to the machine shops, because Tech has great machine shops. You're going to miss being able to use those resources. Research travel. And the final point I have there is that Tech is the best place to get involved that I've seen. And I've talked to friends, UTK, Purdue, Vanderbilt, Virginia Tech, even like at Stanford. And I think Tennessee Tech is the easiest place to onboard from not knowing anything about engineering to getting involved in a club and like doing a cool project of anywhere. So please take advantage of that. And like to the question of how to get an internship, I think this is the playbook of how you do that. Is you get involved and you put those things on your resume, and then places will want to give you an internship. So the next thing to do at Tech is think about the different types of engineering roles that are out there. And so just on the left, I gave you some different titles. So if you're a mechanical engineer, you could be a project engineer, a systems engineer, a safety engineer, human factors engineer, quality, fire protection, logistics and supply chain engineer. So there's a broader spectrum of roles, and like explore those while you're still in undergrad, because you might actually find those more appealing than just mechanical engineer. And on the right, so ways to do that is job boards your dream company. So I would, whatever that is, if that's Lockheed Martin, Northrop Grumman, or look on Dynetics is a really cool company. Look on their website. They have about 230 open jobs now, I think. And read through all the different engineering jobs. Even if you don't know what that title means, look at like the requirements, look at the job description. That's a great way to learn about all these different roles. I think you should have a dream job. So when I was at Tech, my dream job was to be a plant manager. Now I think my dream job is to be a program manager and know what's required to get there, because that'll give you a pathway to think about your career. So daily LinkedIn and Glassdoor searches, and this is going to help you find kind of under the radar jobs. So I'll literally go on Glassdoor and search like engineer Huntsville, engineer Chattanooga, and just look at like what's out there. And that gives you an understanding of the number of jobs, the prevalence, kind of things that are required. I think Amy Smith, I'll answer your question soon. I want to get through a few slides. I think these can be valuable to you guys. So job kind of hunt tips. So try the hardest to get the internship. So the second point is attach yourself from the job searching process a little bit. And this is for a job or an internship. So you're going to probably apply to dozens to hundreds of jobs, and you're mostly going to get rejections. Even when I apply, I get a lot of rejections because you're just not the perfect fit. Or like some jobs you apply to, they already have a candidate in mind. Some jobs, like the job isn't really open. They're sort of curious. They can find the exact person, but just job boards in general, what you see, probably only like 10% of those jobs are really high or truly, truly hiring. And so if you apply to hundreds and you get rejected, there's a chance you could feel bad about yourself, but please don't. Just know like the odds are sort of low that you're going to get any given job that you apply for. So you just need to apply to a whole bunch, basically. And don't feel bad about rejections. They happen to everybody, even the best candidates. So practice behavioral interviewing. If you don't know what that is, Google behavioral interviewing techniques. All companies do it, especially for new grads, and especially the round one interview. And it's a different kind of interviewing. And so I practice a lot with like a business student who's a human resource focus, and they did a behavioral interview in class at Tech, and we practiced on each other, and it was great. I highly recommend you have a strong LinkedIn presence, and build that out, make a few comments on other things, post one or two things, and then connect with recruiters. So there's two big companies called Airtech and Robert Half that are engineering specific recruiting companies. And so just go in there and Google those phrases, and you'll find a bunch of recruiters and add them and just message them and tell them a little bit about yourself, because they get paid for placing people. So they might get $2,000 or $3,000 from a company for every engineer they place at that company. So they have a really good network. And the second is company specific and campus recruiters. So Tennessee Tech probably doesn't have as many dedicated campus recruiters. I know like Denso has a campus recruiter for Tennessee Tech. But Google, Lockheed Martin, if Lockheed Martin, it's a great company, or SpaceX. So Google SpaceX campus recruiter. I know they have at least 5 or 10. And like, that's the person that you should be reaching out to at the company. And yeah, send them a message, try to connect, send them multiple messages, introduce yourself. Okay, so next, network, make friends, and be a nice person. And this actually goes as well with alumni. So my jobs at UBS, the REU, getting into grad school, my job at Mesa, and my job at Dynetics all came from people who both I'd formed a relationship with and were Tech alumni. And Tech alumni are very generous, love to help out. So I highly, highly recommend that you do reach out to alumni. So, like, I'm an alumni, maybe you know me now, but ask your professors, like if you have a company so if it's like Google, go to somebody in the CS department and say like, hey, I want to work at Google. Tech has alumni at Google. I think Tech has alumni at SpaceX, and Tech has lots of alumni at, Lockheed Martin, for instance, and ask the professors, you know anybody, or go into your LinkedIn and do an advanced search and search for Tennessee Tech alumni who's at Lockheed Martin. And that's a great way to, and if you reach out to that alumni, they'll be responsive and you can talk to them. And then, so the last point, personalized resumes, is for each job. Look at the requirements for the job and then like match your resume, have similar keywords to what that job is asking for. And the reason is, whenever you apply, you're going to upload your resume to their website, and the website uses these automatic word scrapers, and they try to match phrases and words from the job description to the resume, because any job you apply for, there's going to be like 500 applicants, especially if it's a good company. Definitely that kind of number, and nobody looks through all of them. They use automated tools. And so if you match as many words and phrases as possible, you're going to have a better chance of getting picked up on that tool, which will then allow you to be seen by a person. Okay. So this is kind of my job hunt. What I think sort of a ratio of what you apply to what you might get. So for instance, if you have a very strong direct relationship with somebody and you apply to the job, 50-50 chance. If you have a strong passion or interest or club that really well aligns with that company, maybe 25% chance of getting a job you apply for. If it's just a job you apply for at like the Tennessee Tech Job Fair, which is great, you need to go every year. You need to practice introducing yourself. You need to look up tips for how to connect with people at job fairs, because it's a weird environment. So train yourself for it, but maybe a 10% chance at a job you apply to there. And just an online job board, roughly 2% is sort of like a hit rate that I would expect. So whenever you're interviewing, so research the role, research the company, research the product you might be working on. Hold up. Sorry, tornado watch came up. So, but essentially, as much as you would prepare for a test, like think about how important getting a job is. I think it's much more important than getting an A versus a B on a test. So the same preparation that you would give for a test, I think prepare that much for the interview. Have an answer for every point on the job description. So look at like all the requirements and all the responsibilities, and either connect it to a story of something that you've done, or if it's something you don't know about, research it. So like if there's a thing on a job board that says you need some ANSYS skills, you don't have any, we'll spend an hour learning about ANSYS. So have a bank of stories ready for the behavioral interview. I won't go into that, because if you research behavioral interview question, you'll kind of learn about the STAR method, the stories that you need. Have a great answer to tell me about yourself. It should be extremely sharp. 75% of interviews, that's going to be the first question. And please go research how to, like, Google how to do a good tell me about yourself, because tell me about yourself doesn't mean, okay, I was born here and I went to high school. It doesn't mean that. It means something very specific and different in the job context. So learn about that. Dress one level above the normal work attire. So if you're going to a shop floor, don't wear a suit and tie. That won't look right. You know, you want to look like you're in the place, but just sort of one level above the normal dress attire. And so a lot of plants, they're kind of wearing slacks and like a button up, or a polo shirt, for instance. Maybe you wear slacks, nice shoes, and a button up and a tie, for instance. A lot of your first interviews now are going to be over video. So I highly suggest that you have good lighting. These are some things I didn't do today, for instance, because I've had a very busy week. To have good quality audio, that means so like a headset, or call in through your phone for audio. Good video, so maybe a webcam, or make sure your computer webcam is like 1080p. It's good lighting, so use like natural lighting from a window or something, so that you're not in a totally dark room. So I suggest using your phone for audio, because even if your Wi-Fi goes down, then you have that phone. And then a printed portfolio, different your work products that you've worked on. And finally, I think this is really important when you interview. Make sure that they come away thinking, "Wow, that's somebody I want to work with," because about half the interview is what you say, and half of the interview is how you make them feel. Humans are very instinctual people. It's not all about analysis of your resume. It's a lot of like, do I want to work with this person? Is how they're going to choose who they hire. So these are things that surprised me when I started working. So one, lack of job training program. Very few companies have had like a formal job training. So the antidote to that is just like jump in and learn by doing. So I've seen a lack of supervision, which means I'm not being tasked every day. Like I have to go out and get work. And a lot of jobs, when you first come in, you're not integrated in the projects. People aren't just gonna be handing you things all the time. Sometimes they will, sometimes they won't. So the antidote there is like volunteer for new work. So the third is you're going to be allowed to take on challenges you don't feel qualified for. And so I kind of wrote there, everyone is making it up. And every company I've been to, like I've been surprised, like nobody in the real world's maybe expert in everything. People are just sort of trying their best, asking for help. So don't be afraid to do that. It's the important finance and engineering. And so a lot of what I do now is sort of financial aspects of this program. And so, I said, if you can't financially justify it, it won't happen. And, in all manufacturing plants, if you want to change anything, you have to do a financial feasibility study to make that proposal. Second to last thing is industry/company best practice may not be the best practice that you learn in school. And so you need to learn like in your job what they expect. So in terms of like doing a drawing, I'll give you an example. In the utility industry, so if you were doing a drawing and you had a lot of symbols, and you would probably learn in school, you better have a table that says what all your symbols are. Well, in the utility industry, maybe the drawing is so busy already, they say we don't have room for that table. And if somebody doesn't know what those symbols mean, they shouldn't even be looking at this drawing. So don't include the table. And so you need to learn what your company wants in terms of like document production, for instance. Another thing that is kind of funny is school is very cyclical. So you have these homeworks, tests, midterm, final, breaks, and you have some sort of like seasonality to your work. But when you start working, it's just going to feel like it's going to go on forever. You got 40 years. And so you got to make sort of short-term goals that keep things interesting for yourself. Don't have a ton of time. So some ways to move ahead. So engineering adjacent skills, which is like project management, which is what I'm learning and doing now, or learning logistics or other things that like help if you have mechanical engineering plus project management, that makes you more valuable. I put go deep on there twice. It's funny. So get stuff done is really important. Like be somebody who actually completes tasks, not just starts tasks. And then the go deep is like kind of become an expert. So I've been dealing a lot lately with seals. So for the crew module, we got to keep the environment in this pressure vessel. And so there's this Parker seal manual that if you read and you understand, and it's very complex, but you will be an expert in seals and you will always have a job, because every industry has to keep stuff out of equipment and keep fluids in equipment. And so that's an example. Or like the Fastenal fastener catalog. If you really understand how to pick the right fastener for an application, those sound boring, but those catalogs exist and you can like really learn those products, and then you're going to be the go-to person. So here's certifications. They make a huge difference because they help you stand out. And like, if you're looking for an internship or you're looking for your first job, a lot of engineers out of any college, they look very similar, but those certifications can make a difference. And so I have a list of them here. PMP is what I'm working on now, professional engineer, Lean Six Sigma. All of these are valuable. And then also like a lot of professional organizations, like Society of Manufacturing Engineers is a professional organization, for instance. They have their own. So INCOS is the Systems Engineering Professional Society, and they have their own certification. And so I'm trying to get PMP and Lean Six Sigma right now, are the ones that I'm working on. But I think they're hugely valuable. So learn how to use Outlook. I highly recommend you go on Google and just look up Outlook tricks. You're going to live in Outlook, so it's very valuable. Learn how to use Excel, and there's tons of free templates online, beautiful templates. Download and start using these templates, and people will think you're a genius, but really you're just using great templates. Get a task management system. So I use a Kanban board to manage my personal tasks at work, but like, tech, and because school, this is a cycle to it. So I just use the paper planner, but like work, things are a little bit more they're too complex. They're moving too fast. And there's too many things to keep it in a paper planner. So I use a digital Kanban board. So there's ones like Trello, or I'm using Notion for it. Highly suggest that. So next, I say track your time. And there's basically a lot of studies that show most people only work about 4 of the 8 hours a day. And so I said, work at least 6 hours a day and really keep track of if you're working or not. Somebody told this to me, and it made a big impact, but managing your career is like a job in and of itself. It's really your second job. So you do your daily work, and then you need to step away and think about, what's the arc, what skills do I need to learn, etc. Oh, that's funny. I thought I had another slide. There it is. Okay. So two things to absolutely not do. So don't wear AirPods at work, even though a whole lot of people do, especially our age. I've seen these like get ripped out of somebody's ear by a manager. Now, if especially like walking around the halls in a meeting, if you're at your desk and you're working, that's different. So I've got some Bose headphones that I put on if I'm trying to do deep work, and people understand that like at your desk, that can mean, hey, I'm working on something. But seriously, don't distract yourself at work. And then also, I've seen so many people kind of sit at their desk and watch gaming videos while they work. And at one of my roles, somebody was fired for this. It was a good employee. They did their work, but always on the side, they had, 2 screens. And on half of one of their screens, they always had a video of somebody playing a video game. And I just really encourage you not to do that. And if you need to take a break, like go to your car, go to the break room, spend 15 minutes watching something to cool down or whatever. But don't sit at your desk, because if a manager or a customer or somebody comes up behind you and sees that, it's just gonna make a negative impression. All right. So closing thoughts is like, you can accomplish anything with your Tennessee Tech degree. So I was able to go to Stanford. Now I have what I would consider to be, dream job. I have so many friends who I graduated with at Tech that are at, PhDs at Vanderbilt, masters at Purdue, have great jobs. There's lots of people who went to Tennessee Tech for engineering and are now engineering leaders that are making great money and have fulfilling careers. So you can absolutely do it. Be willing to keep learning. A 1% a day improvement makes a huge difference, and there's some math to prove it. So just keep trying to get a little better every day. And next, when I was at Tech, I thought graduation is sort of the finish line, and then my life will be easy. But graduation is really the starting point, and the career is really the game, right? School just gets you to the game. So thank you for listening. I hope you got some value out of it, and I'd love to answer any other questions and have a conversation. I don't know how much time we have, but I can stay, like, if anybody else can stay on a little longer, I could stay on, 5 or 10 more minutes and have a conversation if somebody wants to talk about something. Yeah. So with that, I guess I'll close, and Emmanuel and Dr. Fadon, I have another question in the queue, but what do you guys think we should do?
Yeah, well, first of all, Nick, thank you so much for all the information. I anticipate everyone learned a lot. I personally learned a lot as well, so thank you so much for that. Dr. Verdon, if it's okay with you, until you have to leave, we can keep on asking questions.
Yeah.
And then whenever, Nick, whenever you need to leave, just have a closing point and say, like, I can answer 2 more questions or anything like that. But,
well, yeah, I went to this one so it says Annie Smith, but so it says kind of like life's difficult now, COVID-19, opportunities are limited, discouraged us a lot. What would I recommend? So first of all, and what do I see in the near future? First of all, I really believe that with the vaccines, things are lifting. I'm seeing that a lot in my own company. We went from virtual to returning to work, but also I don't think opportunities are limited, actually. I think if you look at the unemployment numbers, they're very strong. If you look at manufacturing sector, it's strong and growing, and there's certain hubs of special strength. So one is the aerospace industry, especially like hypersonic weapons, missile defense, like all hypersonic glide bodies, and space is extremely hot right now. And so like, and Huntsville is the center of that. So Florida, Huntsville, Colorado, Texas, and the LA area in California are all centers of aerospace. They're all booming. So there's like hundreds of open jobs here in Huntsville. Just look engineer Huntsville and you'll see literally like 2,000 jobs open. Another industry that's booming is a lot of like computer chip manufacturing is moving back to the U.S. And strangely, a lot of it's in Arizona. But TSMC is investing $8 billion in a plant, and Intel's investing $20 billion in 2 plants. That's some of the biggest industrial investment in the United States, really ever, into chip manufacturing, because there's a shortage and there's trade tensions. And so I would look for the opportunities. And so there's certain industries that probably aren't great right now. Maybe auto is slow. I'm not sure, but in general, I think it's a good time to be an engineer. It's just going to keep getting better. So got a question here from Astrid. Good to see you again, buddy. Since I was in academia, now in industry, which one do you like more? Can you make some pro and cons of them? So, based off the decision that I made, you can say that I like industry more. So there's a few reasons. I think I could have been happy in either place, but I really like working as part of like multidisciplinary teams. Academia is very individual, insular. You're not really working part of a team. So that wasn't an environment I wanted. In your career, you kind of have more paths of progression. So in academia, you have like associate professor, assistant professor, full professor, and then you're doing that the rest of your life. In sort of a more normal industrial career or industry, there's so many more types of roles that you can move around to. There's so many more levels of like leadership. Also, I really like managing and encouraging people. And so like I wanted to be a people leader, which is not really something that you can do in academia. And finally, just for, I think, where my family is at now, like 6-year-old, 5-year-old, 2-year-old, I needed to make more money, and it was gonna take me like 4 or 5 more years. Well, it still would, right? So I can still go back and get my PhD, but it's gonna take 4 or 5 more years, and then I'm probably gonna have to do a postdoc. And then when I get out, I would make the same amount as a professor as I'm making now, and so it's hard to justify academia. Also, I think there's gonna be a lot of shakeup in academia and higher ed because of like things like online learning, like digital learning. So I think that profession is going to look a lot different than it does now. Yeah, so that's kind of my answer there. So hey, if anybody else, you can like jump on the mic, ask a question, or if there's no more, we can wrap.
Before any questions, everyone, first of all, we just want to say thank you to Dr. Fadon, the SME chapter at Tennessee Tech, Nick, especially you, Cynthia, and Michelle for putting this all together. We greatly appreciate it. At this time, we're going to go ahead and stop the recording so anyone who needs to make their lunch meetings can go.